Okay, so we're going to talk about probabilities involving two dice. All right, so you all know what dice are. Dice, six-sided cube with the numbers 1, 2, 3, 4, 5, 6 on each side, right? Okay, so in order to look at what happens with two dice, we're going to get into sample spaces. So all a sample space is it shows all possible outcomes of a probability experiment. By probability experiment, all we mean is something like rolling two dice, like we're going to look at in this lesson, or flipping coins, or spinning a spinner, or, whatever. Something where we're looking at some sort of game, or, pretty much anything, and then looking at the experiments in terms of probability, and looking at the results in terms of probabilities. Okay, so to make a sample space for rolling two dice, all right, this is the way we're going to construct it. So let's assume that we get a 1 on the first roll, okay? If we get on the 1 on the first roll, we can also get a 1 on the second roll. So I'm going to write it like that. This is first dice, second, okay? So it's just like a coordinate pair, but instead of x, y, it would just be the first roll and then the second roll. Okay, if we get let's keep assuming we get a 1 on the first. Okay, if I get a 1 on the first, then I can get a 2 on the second. I can get a 3 on the second. I can get a 4 on the second, a 5 on the second, and a 6 on the second. Okay? Okay, now let's assume that we get a 2 on the first. I get 2 and a 1, 2 and a 2, 2 and a 3, a 2 and a 4, a 2 and a 5, a 2 and a 6. Okay, again, all we're doing is listing all the possible outcomes. So this result right here would mean that the first time we rolled the die, we got a 2. The second roll, we got a 4. Okay, so to continue making the sample space, the logical place to go next, let's assume that we got a 1 on the first roll. In the second column, we assume that we got a 2 on the first roll. Now let's assume that we got a 3 on the first roll. So we'd go like 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6. Okay, let's do the same thing for 4. Okay, and to finish our sample space, let's assume we got a 5 on this first roll. Okay, and then to finish, let's assume that we got a 6 on the first roll, so that would go like 6, 1, 6, 2, 6, 3. Okay, so in the classroom where the assignment is, you should have noticed that there's an extra handout. The extra handout is I gave you 4 copies of this sample space. Okay, so when you're working on problems, you can either print that out and you've got 4 of them on there. They're the same exact thing, just so when you're doing questions, you're going to be writing on it, and then you're going to have 3 other lists to work from, or write it out, okay? Because you need to have this list, you need to have this sample space in front of you to answer the questions. Okay, let's take a look at what questions involving this look like. So if 2 dice are rolled, find the probability that their sum is greater than 10. Okay, so we have all the possible outcomes on this list. So we want to know the probability that we've got a sum greater than 10. So let's make a list of the sums for each of the possible outcomes, okay? So the sum here is 2. I'm going to circle the sum for each. 3, 4, 5. 6, 7. Okay. Okay. Let's see. It's getting a little. Oh, actually, I've got more space on the right here. Okay. Okay, and then we'll do the sums on the bottom. All right, so we're looking for the probability that their sum is greater than 10. Okay, how many are greater than 10? Well, I'm going to take different color. I'm going to check off the ones that are greater than 10. In the first column over here, none of them are. Second column, none of them are. Third column, none are. Fourth, we have a 10, but it's got to be greater than 10, so that's not going to work. The fifth one, we have an 11 over here. I'm going to put a check next to that. And then the last column, we've got these two, okay? So it's going to be 3 out of, notice we have six sums for each assumption we made on the first roll. So 6, 12, 18, 24, 30, 36. So it's going to be 3 out of 36. Okay, and of course, we're always going to simplify our answer. It's divisible by 3. So that's going to be 1 over 12. Okay, I'm going to erase the blue so we can use this sample space to answer the next questions, okay? And again, when you're doing this on your own in the online assignment, you want to use that handout that I included, and instead of erasing, you can just go to another copy of it. I gave you 4 copies on a sheet. You know, if you have a printer, print out a couple of sheets. Okay. The next one we'll do in the green. If 2 dice are rolled, find the probability that the sum is even. So let's check off all the even sums. Here, here, here. This one, that one. 6, 8, 10, 6, 8, 10, 8, 10, 12. Okay, so we have 3, 6, 9, 12, 15, 18. So we have 18 out of 36. Okay, which is 1/2 when you simplify. All right, so the probability that their sum is even. So let's erase all the green. So we could check off all the sums that are even. Oh, wait, I'm sorry. This is supposed to be less than 5. Oh, I'm sorry. Change that on your sheet. It didn't. When I cut and pasted, it didn't come through. So that's all right. We'll fix this now. Okay. So let's do this one in blue. Okay, so less than 5, we've got 5, not less than 5, that doesn't count. None less than 5 in the 4 column. none less than 5 in the 5 column, none less than 5 in the 6 column. So we have 1, 2, 3, 4, 5, 6 out of 36, and those are each divisible by 6 when we simplify. So that's going to be 1 over 6. Okay. And the last question, find the probability that their sum is divisible by 4. So numbers that are divisible by 4 would be like 4, because 4 divided by 4 is 1 with no remainder. Another number divisible by 4 would be 12, because 12 divided by 4 is 3 without a remainder. If you have a remainder when you divide by 4, it's not divisible. Okay? So let's check off the sums that are divisible by 4. We've got a 4. We've got another 4, an 8, another 4, an 8. We've got an 8, another 8, another 8, and a 12. Okay, so we've got 1, 2, 3, 5, 6, 7, 8, 9. So that's going to be 9 out of 36. Each divisible by 9. So that's going to be 1 over 4 for our final answer.